We're live? Okay.
All right. Welcome, everybody.
Yeah.
Welcome here in San Francisco.
Yeah.
And everybody on the live stream. Thanks for tuning in. And with me, I have Sean Bennett from Udacity, one of our instructors. Colt McCandless on the big screen, coming to us from Hangout. And myself, Peter Lubbers.
Yep.
So this is our second episode of our Udacity HTML5 game programming study group. And really excited to talk a little bit about Unit 2 today. We're going to talk about all of the questions you have. And we have about, 60 or 70 people here in the room. Take questions from the room. And then we have a little bit of a technical problem here that we have Colt via the Hangout today.
Yeah.
But we should be okay, and just bear with us with some of the delays with showing some of the bits and pieces we want to show.
For the people on the live stream.
Sorry about that. I got in a fight with a honey badger, and as everyone knows, they always win.
Yeah.
So unfortunately, I got some stitches and some rabies shots and some other shots that they said were for rabies, but like honey badger rabies, really weird. I didn't trust the doctor too much. But hopefully I'll be back up next week. Don't worry about me.
Yeah. PR must love you.
Honey badger. Okay.
There's an idea for a game.
That's right.
Yeah.
Idea for a game, Gold.
Yeah. Honey
All
badger
right.
fight.
So wanted to start opening it up. Maybe just a quick round through the room. Like, what are some of the questions you might have? Are you have you been able to go through the units? What's the general feel from the room? Okay.
Yes.
Okay. Good. We got a couple of people that have been able to finish it. So great. All right. So I guess we'll jump over to the questions. Are there any questions right now from the room? We have a mic up front.
Yeah. So feel free to start asking.
The first question on its way.
Yeah.
Thanks.
Is this on?
Oh, it's on. It's
on.
Okay.
But
In spritesheet.js, there's a global variable with an associative array gSpritesheet where the key is the spritesheet ID and the value is a spritesheet object. So why not have that value be an object that has a couple fields, the spritesheet object and the index in the sprite array? Because otherwise your getStats method is searching linearly through the sprite array every time to find the actual sprite.
Okay, so Colt can probably answer this better than anyone. The question is, we've got this associative array declared globally in the spritesheet class that uses the name of the spritesheet to grab the spritesheet object. And the question is, why don't we do the same thing with the sprites in the spritesheet? Is that correct?
Yeah, so from the sprite ID we could get the index into the array, otherwise we're actually just marching through the array every time.
Right, so we could get the ID from the spritesheet instead of walking through the array and get stats linearly each time.
Yeah, so it is definitely one of those situations where premature optimization is the root of all evil, right? And we saw a unique instance to talk about the atlases at the global level and the need for that to be grabbed by a string name, because that's actually what, as you start progressing through the course, you'll start realizing that how we load our texture atlas assets are a little bit unique in whatever. And we just kind of lazily didn't apply that same hashing function to the sprites themselves. There's no dark magic here. Good programming should say use hashes everywhere as long as your memory model allows you to. We just didn't get around to that. No dark magic here. Don't read into it. I'm just a horrible programmer. I think that's the right way on it.
Thank you.
all right, thank you, Cole. All right, so okay, we have another
question from the room.
Question from the audience.
So I have a general JavaScript question.
Oh, okay.
In Unit 2, I found myself typing in hash keys that don't exist because I can't spell very well. But I was expecting an error to come back, and instead I was getting an empty list. And so when I was trying to debug, I couldn't figure out what was happening because I wasn't getting any errors. And when I went line by line and figured out I forgot the S on frames, that's when I figured out that JavaScript is spitting out an empty list for me. I was wondering, what's a good way to debug like that, debug something like that, and if there are any other JavaScript quirks that we should be looking out for as we progress, because I kind of spent a little too much time on something that was really kind of trivial.
Yeah. Do you want to take
Do you
this
wanna
one?
take it?
For it. So the question is, are there any JavaScript gotchas that we need to look out for, or quirks? Specifically, the one you were talking about is where JavaScript will basically just create an empty field in a dictionary instead of throwing an error saying that that entry doesn't exist. And the
gotcha is the whole language.
Yeah.
The whole language is a gotcha.
Yeah,
So start with that assumption as a mental model, and it'll make your life a lot easier.
Yeah. The way JavaScript was designed wasn't exactly well planned. It was designed, I think, in 6 days. Was
That's
it?
right. That's
yeah.
right, that's right.
And
Very
it's
quickly.
basically another language called Scheme that is totally different from the way JavaScript looks, but then kind of wired and mishmashed together to look like Java because that was popular at the time. So the guy who wrote it, his bosses, told him to write it to look like Java. And there are a bunch of other gotchas. This is a good one, the this versus that problem.
Yeah, I'm not sure that particular one I mean, yes, you should be getting, it would be great if you got better error messages for that, but basically that's just like it's doing stuff you're not expecting it to be doing. Other gotchas, I'm sure you're going to be running into lots of them. Can't give you a list of them right now, but maybe we'll find a couple more here.
Yeah, we'll try to talk about some more.
One of the good things, so which browser are you using to debug? Okay, so definitely always keep the Chrome developer tools open, because they will pick up a lot of errors that you don't necessarily see or may not be logged to the console by the program, but they might still be easily accessible from the console itself, right?
Yeah, it's definitely a language with a bunch of different issues. When writing the grading scripts, I ran into the this versus that problem, where this does not mean what you think it means based on what this means, the keyword this, in other languages. And the basic rule there is don't use this, because it's a lie.
This is a lie.
So yes, there are a bunch of gotchas. I would love to point to some resources for listing some of those out. We might actually do that in some of the
Yeah, there's a
course
great
notes.
great book, JavaScript, The Good Parts.
Fantastic book.
That's a great resource that kind of also really digs into what's behind all these things and why you are not seeing those things. So that would be a good resource just to...
Yeah. The other thing that we are doing that we're putting into the code editor on the site, on the Udacity code editor, is we're putting in automatic JS hinting. And JS linting or JS hinting is just basically a preprocessor that will run through and catch a whole bunch of these different gotchas, including syntax errors. And this is used here, but it wasn't previously defined. Maybe you don't actually want to do that. I would say JS lint or JS hint, depending on which one you prefer, is probably one of the better tools that you should use whenever you're developing JavaScript.
There's a plugin for Sublime
Yes.
as well. Like I think it's Sublime Linter.
Sublime linter. That's
Sublime
what it's
Linter,
called.
definitely
Yeah.
get that. So if you write it in Sublime, it'll pick up a lot of possible things that will trip you up for sure later.
Yeah.
Right.
And what we're running on the Udacity site is basically another version of something like Sublime Linter. It uses the same backend JS hint
Right,
service.
which just uses those packages,
Yep.
right?
So
Okay.
that should help a lot.
Thank you.
Cool.
I know we're staying on a schedule with this study group to go a unit a week and all that, but I read something about Udacity and in the initial formation of Udacity that they thought courses should have strict time limits and things like that. I assume this course is just going to be open forever, and anybody
Yes.
can start it at any
Yes.
time. My question was, the knowledge that we gather from this, if we start adding knowledge like the things we're mentioning in the answers to these questions, those could be shared with the community over time, and that's the philosophy that you're doing.
Yeah,
Right.
that's really one of the, did you get that question cold?
I don't think you did.
All right, so basically the question was, we are going through this course on an 8-week study group, but what happens after that? So a couple of things. So Tony mentioned there's a lot of great stuff that's coming out. So clearly these videos will be recorded and posted, but also the forums are full of things that people have gotten. That's actually one of the nice things that I find of this kind of scale that we're working on. It lends itself really well for sort of basically this more and more information being amassed in this, in the different bits around the course, like the forums and so on.
Right. And we've also got a wiki attached to the course as well. And there have been some very industrious students.
Some of your
There's
tools.
some additional tools that you can use.
Right. but just to be really clear about the Udacity model, and basically the idea is completely asynchronous learning. So you start a course, you can finish it whenever. There's no December 16th, it's done and there's the exam. That of course has its good and bad sides, right? The good side is you can do it whenever you want. And the bad side is
you can do it whenever you
want.
want.
Right? So you may not have that pressure that you might have if you were to go on a certain schedule.
Right.
Basically, when we were not 100% ready to launch everything, so we felt like, hey, this could be a great opportunity to do it a week at a time. We have most of everything done now, but it's like, hey, this would be a good opportunity to try out this system of, one a week, have everyone do that. But as soon as this course is over, or this study group is over, rather, people can start that day, and they can finish it as soon as they're done with the course. So there's no time limits after that, right?
And as to the initial part of your point, that the initial philosophy of Udacity included, timed courses and deadlines and things like that, we did actually try that at first, and we found that actually a lot of people had problems with it just because, people have lives, basically. If you're not, going to school full time as a student or something like that, it's actually very, very difficult to get through one of these courses, especially when it's not, directly tied to some kind of institution that you're a part of. So we had a lot of people that just couldn't finish on time, and we would rather just make it available to everyone all the time. And yes, that does, kind of drop some of the incentive. You don't have that external motivation that a deadline provides. But we feel like the idea there isn't we should put that external motivation back in, but rather we should improve the internal motivation that you have for the course by making the course exciting and interesting and something you really want to learn.
Yeah, perfect. Good. Well, let's take a. Yeah, go ahead.
Just to comment on his debugging issue, I just finished a JavaScript course in the fall and looked at a number of different tools, and clearly people are trying to solve these problems. And so, Dart is there to try to address some of these problems, and there's different ways to approach and compile down to JavaScript. But prototypal inheritance is really important to understand and understand well. And if you can stick with ECMAScript 5, if you can, and use strict, it will catch some of the things for you that will still trip you up in ECMAScript 3. And the really nice thing I learned was TypeScript from Microsoft allows you to use some of the features of ECMAScript 6 now, and it will backport it to ECMAScript 5, and it catches a whole lot of errors because it's asking you to optionally type in the TypeScript environment, but it just translates it all out to regular JavaScript. So it's an easier, for me, way to develop JavaScript and catches a lot of my errors.
Yeah, thank you. Actually, take a quick commercial break. As you guys know, I run the San Francisco HTML5 user group. A lot of you are familiar faces from that group, but if you're not part of it, sfhtml5.org is where you can sign up. And this Thursday, and that's why I think about it, that we have a meetup, and there's still space for that, on Dart. And two specific areas of Dart. We have Seth Ladd coming in to talk about Dart and web components, and a more deep technical session with John McCutcheon. So that's going to be a really good session to learn more about Dart. And in addition to that, we have, which unfortunately is already sold out, but there's a wait list, a Dart for Breakfast Code Lab on Saturday. So if you're interested in that, definitely sign up, put yourself on the wait list, because many times it's easily that 20 or 30 people will drop off the wait list and they will just RSVP no, and you get automatically notified. So if you're interested in Dart, this is a good week to learn more about it.
And Dart is a great example of one of those languages where people are trying to solve those problems, those JavaScript gotchas. And there are a surprising number of those kinds of projects centered around compiling to JavaScript. It's a very interesting space right now.
And can I throw an extra point in there?
Sure.
Yeah.
It's worth pointing out that JavaScript is actually a pretty young language in terms of languages. If you look at the number of features that people are trying to cram into JavaScript, or as I like to say, kind of Frankensteining on JavaScript right now, it's very much a result of the fact that the language was designed for one specific purpose, and people said, this is the only thing the web should do, and then the web evolved. And we're still trying to kind of lock ourselves into this mental model. And I'll say this again and again and again, and I know this may be heresy to some web developers, but it's not about the language, it's about the experience, right? It's the technology stack shouldn't matter. We put a rover on Mars using Fortran. Does that mean that you should program the web in Fortran? Absolutely not, right? Like the language doesn't matter, it's about the experience. And JavaScript is still really new, and there's still this dogma kind of sitting around it that it should be light and it should be nimble. But then you have the fact that you have native applications kind of starting to compete for this ecosystem where you've got web apps versus native apps, and I go to a website and it tells me to download the native version, and you get all of this stuff going on there, and it's directly coming back to the fact that this is a young language, it doesn't have all the features. It wasn't designed to fight this battle right now. So a lot of people had to go back to the drawing table and kind of rejigger JavaScript. The number of developers I've talked to that have written their own front-end compilers for JavaScript is really staggering. Like people who are like, yes, write it in JavaScript, but then my compiler will go through and auto-inline things, right? Or do auto-completion. Or, you can actually hint that this might be an integer, and then I'll check everything and make sure that that's okay. These are kind of tried and true development patterns that have kept programmers sane for 30 years now. It kind of draws the line between JavaScript being a hobbyist language versus a serious language that people can get amazing stuff done with. So I'm really proud of what JavaScript has done so far. I think there's still a lot of discussions about what it means to do to become a big boy language and use the potty.
No,
All right,
that's
so
beautiful.
in summary, young language, like yourself, Colt.
Yeah.
So take a question from the moderator. So in previous session, you told us you will not talk about existing libraries, but Box2D. What do you think about the other ones? Is it good to use one of the existing ones? So I think you did a little research on a couple of...
Well, it depends on what you mean by existing libraries. Do we mean like game design libraries? Or do we mean more general web development libraries? Because there are really two questions there, depending on what they're asking. So let's answer both.
Yeah.
So the ones that I'm most familiar with, game library-wise, and Colt probably knows quite a bit more about this than I do, would be Impact.js and Create.js. Create.js is kind of more along the lines of what you would get from, if you're familiar with Flash and ActionScript, it's very familiar to those developers. Impact, I don't know as much about, but I've heard very, very positive things about it. Colt, do you know about any others?
You should definitely check out Easel.js. It's a fantastic translation library that kind of sets up JavaScript and HTML5 to feel more like a Flash/ActionScript environment. That one's a pretty good one too. Other than that, I mean, you've got the new Cocos 2D HTML5. So basically, they took Cocos 2D framework from iOS and actually made an HTML5 version. Then you also have the Moai framework, M-O-A-I, from the guys at Zipline Games, and they actually have a setup there that'll export to HTML5, if I recall correctly. So there's not a lack of this stuff floating around there. Most of it kind of boils down to what we're teaching you in this class, right? You basically need an entity framework that's hierarchical and object-oriented. You need some ability to have a concept of a sprite or an instance that can be rasterized to a part of a canvas. You need the ability to sort of have a loading manager, and you need the ability to place sounds, right, and load scripts asynchronously. These are really all these other frameworks do as far as games frameworks are concerned. So hopefully by the time you're done with the CS255 course, you should be able to cover the full spectrum of what these other frameworks offer you, give or take 1% or 2%.
Yeah, and definitely try out those things, right? If there's nothing wrong with them, we just took them out to simplify everything, but we certainly didn't mean that, okay, that's the only one you should be using. Just feel free to use whatever works for you.
Plus, from our perspective, it's, at least from my thinking, it's often better to learn how things work under the hood rather than just using a framework, and then when things break, you don't really understand what's going on.
Except for the box2D stuff.
Except for the box2D stuff, yes. Ooh, that would be dragons.
All right, that question, by the way, is from UKL in Paris. So we have a next question. That is from Philippe Coco from Washington, D.C. So I'm a graduate from the CS253 course, the web dev course. That's the blog, right?
Yep,
Right,
yep.
building your blog.
Yep.
And one of the best things about this, with our own project to work on as the class followed along, how would you suggest we set up a simple game project to develop as we take the class? So I think the first thing, all of the grids code is on GitHub, and you can just grab it.
Yeah.
So that's
It
the
might
first
be on
thing.
code.
Oh,
Google,
sorry. Yeah,
actually,
sorry.
So.
I say that.
But you can grab it from,
Right.
yeah.
So if you go to gridsgame.appspot.com, then you will find it there, and
It's linked
you'll
right from
know
there.
that it's not working currently. We're working on that.
Is that the
right?
compute engine thing?
Yeah.
Yeah, that's the compute engine thing.
But there's a link at the top. Let me just show that real quick.
There we go.
That's good. Here, and you'll have this nice link here.
See the source code.
We'll see the source code here, and you can just grab it from here. So that's definitely something something to keep in mind. So there's that, and then there's tons of other things you could potentially download. And I think Dan was here in the beginning saying maybe people would form groups to create a game together. If you do that, then of course
Yeah.
that's a good way to.
And I think the contest is probably a big part of this, building your own project, especially for something like a game. It's building something that you want to build rather than, just a project that we give you. Having a project that you want to do on the side is very, very valuable. And figure out something you want to build and build it. That's what this is about.
If you want to take a look at this from a technical baby steps to move forward, obviously just create a folder on your desktop with an HTML file, and then as you kind of go through these quizzes that we give you, the way that and Sean is a mastermind here of taking the Grit source code and turning it into bite-sized chunks for the class. So as you guys are going through this, definitely give props to him for separating all this data. But effectively, our goal is by the end of each of these units, you should literally be able to take the answer from the quizzes and copy them into a folder as a JavaScript file and start using them, right? So the atlasing, the sprite animation stuff you're going to be doing, map loading, rendering, physics, like you literally take your answers to the quizzes and copy paste them into a file and move from there. And then if you want to see the definitive source that all of this kind of stemmed from, check out the Grits code base.
Yeah.
But it should be really easy for you to actually just have a folder on your disk that has an index file, and then just link each of your .js files from your units and kind of add those in as you go along.
Yeah, a huge part of the code base doesn't really, it's not specific to Grits at all, right? Most of it is very modular, so just put some different art and sound on and some different entities and go nuts.
Okay. All right, so we have a question from Tony.
Yeah, just a comment on that, just to add something to it. Last week I said I really didn't want to build a game. I wanted to get back into drawing efficiently using the canvas and rather than just being within the bounds of normal HTML5 markup. And so what I'm doing is actually providing a test bed application that I want to share, with the group at some point that does exactly what you're saying. It takes the fundamentals and puts them into something that then you can make your own. And it has a lot of gotchas in it, about scaling and things like that you'll run into, that it's very easy to figure out what the answers to it are. But it's the type of thing that once you strip this thing out, you need something to start with on the other side. So independently of the game, I'm going to take all these techniques and just provide that on an ongoing basis as the units are there. And I know this is the same efforts that everybody's trying to do, but I want to try to make it so that the community can contribute to that. So.
Yeah.
Perfect. Thanks, Tony.
Yeah.
Okay. Taking our question. Did we?
Okay. So no, we didn't do this.
All right,
one.
so how to divide the entire atlas in sprite sheets of entities. The sprite sheet class used to store and draw sprites, draw entities that be in entire atlas because the structure of JSON atlas file. Okay. Something better than string manipulation of the key from Luis in.
So I've been actually meditating on this question for a couple hours today, trying to figure out what the intent was. Luis, I give you a lot of respect for this. Is actually a very complex question, and I only speak English and bad English, so I apologize that it took me this long to understand what was being asked. But this is a very, very good question. So basically, this kind of boils down to why are we using the image name plus some weird identifiers as a lookup index into our sprite array, right? And then how does that manifest itself moving forward with like drawing sprite animation classes and whatnot? So the first one I'll say is this, okay, imagine that you're a game developer, or better yet, imagine you're an artist, right? So in the game development world, like I said last week, you're kind of a programmer, an artist, a designer, or a producer, biz dev type who doesn't really do anything. I'm being facetious. They do lots of stuff, like give programmers a hard time. Anyhow, if you're an artist, effectively you have to imagine how an artist is working. An artist is sitting there with some sort of modeling program or Adobe Photoshop or something there, and they're working on a single file, right? They're working on ralphierobot.psd. Now, when they export Ralphie Robot and all his walk frames and plubs.jpg and stuff like that, he just has basically a raw directory of loose assets, or what we call them, right? Now, what's the interesting thing here is when he goes and actually, when the artist and the designer start working together and they create the concept of an entity, they're going to say, this is a robot entity and it has, 7 frames of animation and, here's the sprites it throws out. But basically they're creating a cognitive logical object that references these loose assets. Right? Like that's the critical component here, is that data is being created referencing these loose assets by file name. Now, when you create an atlas, this is considered more of a post-process thing for programmers who are optimizing our runtime and our memory process, right? An artist shouldn't have to change a sprite, save everything to an atlas, update the code, and then load it in the game. We need to make sure that atlasing and the process of atlasing is just a post-optimization that a programmer can do before you actually ship the product. So because of this, we allow the source code to actually still reference the original sprites by their loose file name, rather than some other interesting hash-coded MD5 hierarchy or indexes or anything like that. Now, this is also very important for the sanity of the programmers who are doing the debugging, because sooner or later what you're going to end up with is an artist or a designer is going to come through and say, hey, this animation is wrong. For some reason, I'm getting 20 frames instead of 3 frames. And then a programmer is going to dig down into the depths and actually see the true file name that's being used, and they'll actually be able to solve the problem as opposed to some weird indexed hash. So I hope that sheds a little bit of light on it. Basically, it comes down to understanding how people are developing content in a vacuum, and that atlas mapping and texture packing should be a process done after all of that fact. Like, let your artists and your designers do their job, let them do it in a vacuum, and then the sneaky little bald programmer comes along and optimizes all the assets to get 5 megs of memory back, and no one is the wiser, except for that one programmer and the manager who gives him the bonus for doing that awesome job.
I mean, where does BizDev come in?
They're the guys who complain about the programmer getting a bonus for the awesome job.
Okay. Cool.
Okay.
Well, thanks. All right,
Ooh.
so
This is a good one. Hey,
Yeah.
Why is it necessary to find the center of Atlas images with respect to the original file? I understand why we would do this for a sprite sheet in order to line up animation frames. Is this a concern with Atlas images as well? Oh, I think this has something to do with Box 2D as well, doesn't it, Colt?
Yes, it does. So there's two things here. There's two forces acting on top of the need to find the center. The first is that, as you'll find out in a later unit, that Box 2D actually references an object's position at the center of the object, not the top left corner. We talked about coordinate systems a little bit in the previous units, and when you draw to canvas, the origin is in the top left, but the physics engine expects it to be in the center of the object. So obviously we need to rectify these two worlds. And telling the physics engine to work from the top left actually doesn't make a lot of sense, because you remember the physics engine is also going to be responsible for rotating our objects, right? And anyone who's done sort of linear mathematics knows that if the origin is in the top left, you're going to rotate that square by its corner rather than at the center of it, right? So this is a very important distinguishment between the two. So for that reason, that's number one, that we like to actually draw our images and reference them by the center of the object. The number two, and hopefully a lot of people kind of saw this, is due to animations and trimming. So in the animation process, basically what you'll see is like each sprite image in an animation sequence can be trimmed differently. And because of that, the center of the image, right? Like, so if you got a 64 by 64 and 32 by 32 is the center, that might actually not actually be the center of the subsequent sprites in the animation. And so what happens is you get this image that's, as it's animating, it's jittering, because the true center is actually moving around. So part of the trimming process is to find out what the true center of this animation is, so that we can lock all that together. So basically we've got these two forces that are easier and cognitively more applicable to understand if we're using the center of an image as its true origin rather than the top left. So because of this, we just kind of say, hey, we've got 2 versus 0. Obviously, there's a winner here.
Okay.
great. Okay, next question. I think I have everything figured out, but there seems to be a lot of confusion in the forums. Could you actually fire up Texture Packer, load up assets, export them, and explain what we're seeing and how everything applies to the code? So, Colt, do you want to try that moment?
Yeah.
In the
Yeah, we're gonna try some
Yeah.
high-tech technology here
Yeah.
and see how bad the screen
Yeah.
delay is. So I'm gonna go into screen share.
Hold on.
So before
and
we
see
do
if this
that,
works.
Hold on, Colt.
But before we do that real quick, so the screen share isn't going to be visible, I believe,
Oh, right.
to people
Right.
on the live stream. So we are going to record a screencast of this later on so that everyone can see and put it up so that everyone can see what Colt is about to do. And yeah.
In case you miss it.
Yeah, in case you miss it. So,
So on the live stream,
if
we'll post something
bear
as an
with us
answer
for
to
a
the
minute or
question
two.
and on the forum. All right, so
Go for it, Colt.
the magic
All
of
right,
Hangouts.
so let's see here. Let's do desktop. So can you guys confirm that you're seeing me?
Yes,
We are seeing you.
we see your desktop.
Okay, so this is Texture Packer, and basically I'm just going to kind of walk you through this process a little bit. Now, I've got the Android SDK actually on this disk here. And remember, Texture Packer is a free piece of software, or at least it has a trial mode that you can go test out before you have to evaluate and buy the full version. So to add images to an atlas, you'd go to Add Sprites. And again, I've already kind of loaded some of these default textures from the Android SDK. And basically, you just kind of group select and say, cool, I want all of these. When you add them, they actually all get added to this column over here. And then you can see that the algorithm is working in real time to kind of pack all of these on the texture. Now, if we actually exported this as is, we would get a JSON file or an XML file. Now, the difference is on how you actually get this exporting the right thing is actually in this output, I don't know what the right term for this is, collapsible frame. I think 3D Studio Max coined this
Accordion,
sort of UI
maybe?
setup back in
Accordion?
the early 90s.
Yeah, maybe it's an accordion.
Effectively, you can actually modify this this data format drop down here, and Texture Packer actually goes out to a lot of different formats, right? So like Ogre, Cocos 2D, CSS, right? So if you're actually just taking this right to HTML, Easel.js, and the one that we're concerned with is actually JSON array. Once you set this value, anytime you hit this nice little publish button over here, not sure if you guys can see that on the stream,
Yep.
but effectively what will occur is it'll actually dump out a file to disk and give you some information about that you can then load up a little bit later. So let's load up Sublime Text 2 here, and this is actually the file that we just exported to disk. So what we have here is a large dictionary object, and the only element in the dictionary is frames, and then that's the actual array of each of the sprites. Now, before I dive in too deep on that, I actually want to talk a little bit more about Texture Packer itself. So if you scroll down on the data pane over here, there's an interesting layout section. You can kind of hopefully, let me collapse some of these to just make this easier on the screen. So the layout section here has a couple interesting buttons. The first one is actually this one that's called Shape Outlines. This is really nice because you can turn Shape Outlines on and actually see where everything is on the screen, right? You can actually see that this image here is a lot larger with blank pixels than the actual opaque pixels, right? So seeing this makes you eventually go, wow, it would be great if we could actually not use these pixels because it's just taking up space. And this is where we actually start talking about the trim operation. Now, the video was recorded on an older version of Texture Packer, so I apologize a little bit that the UI has changed. Hopefully the screencast version we're going to do in a little bit will have the updated version for you. If we actually change the trim mode to trim, what you can see is some of those images that were actually a lot larger have been trimmed down to only contain a bounding box that contains the opaque pixels or semi-transparent pixels, basically non-transparent. And of course, because of this, we end up with a lot more free space down here. Now, for any of you who've ever dealt with memory or texture memory as a barrier, an upper limit, you'll greatly appreciate the fact that there's a lot of extra free space. Now, there's also another cool little button over here that says Allow Rotation. Now, Allow Rotation is actually going to give you even more free space, because basically what that'll do is it'll say, hey, assume that we can actually rotate all of these little objects to pack them in even tighter. So this is really, really cool. That basically these two toggles here, and I'll turn these back off so you can see what it looks like again, right? So turning off trim, turning on trim, you can see how the number of free pixels decreases pretty significantly. So anyhow, booting back up to Sublime Text 2, you can see that we've got our array of objects. Now, this highlighted area here actually represents a single sprite that was imported. You actually get the original file name. Again, this is what the artist created. This is what the artist exported, because again, they're just exporting loose assets, and we need to respect that creation process. Then we actually have the frame, which is different than the sprite source size, which is different than the source size, right? So we kind of talked about this in a lot more detail inside the video, and I don't want to go too deep into what we're looking at here, because I think the video will explain it a lot better, because we actually thought about what we were saying at that point. But I think the important part here is the rotated and trimmed flags, right? So let me actually, none of these seem to be here. So let me go ahead and turn on trimming and rotation and go ahead and hit publish again. And this should have updated my Sublime text file. And you can actually see here that we now actually have trimmed equals true, and for some reason this guy wasn't rotated. This one wasn't trimmed and wasn't rotated. Let's see if we can find an interesting case. False, false, true, false. So this one here was actually rotated but not trimmed. So obviously this was a very optimized image that didn't have a lot of wasted pixels, right? But for the most part, what you're looking at here is the data we're using. Now, we kind of covered this a little bit in Unit 0, where we talked about loading and parsing JSON. When you actually call eval or JSON.parse on this JSON data, you're actually going to get back a JavaScript object where each one of these sub-items here is actually an object with .filename, .frame, .rotated, .trimmed, .sprite source size, et cetera, et cetera, et cetera. So effectively, you're building up this internal object in memory that you can traverse as though it were a normal JavaScript object. So this is kind of the basis of everything we're doing here, is that Texture Packer allows us to take all of these loose assets that artists have created, pack them into one gigantic atlas, and then export that data in a JSON file, which makes it very easy for us to then go and I'll show you where this is actually occurring here. I apologize if this is not as large. Nope, plus. Nope. Okay, never mind. But effectively, if you look at client game engine.js inside of the grid source code, you can actually see that we fetch the JSON file from the internet and actually call json.parse on it, which then of course gives us a JSON object. And from there, we actually walk through in very simple form, right? For each key in frames, right? So for each object, we go ahead and get the object, figure out what the frame, width, height, trim, sprite key. Basically, this is everything you guys did inside of your quiz. Again, we're just walking through a JSON object in memory as though it were anything else that we define.
Fantastic. Yeah. All right, so for those of you on the live stream, I know that was very hard to see. We'll record a short video with the same content and we'll post that.
Yeah. And hopefully everyone else will be able to see a bit better the text involved, since that was a bit smushed.
No, the text is perfect.
It was, yeah, okay.
Right.
Should have had Camtasia running there.
Yeah, exactly. Should have done it right away. Right. All right, so a question from the audience.
So presumably the rotation always rotates the same way, so that because it's just a Boolean flag. So otherwise, when we rotate it back, it could end up flipped, right?
Right.
Great question. Does the rotation always rotate the same way? Because it's a Boolean flag that would.
No, to my knowledge, and I actually have to kind of poke a little bit of problem at the texture packer guys. Is that if you actually export the data file as an XML or as a plist, you actually get proper information about rotation data. Where in the JSON format, for some reason, you only just get true or false. And I'm not really sure if this is just a bug or if they think that this was like cognitively like, yeah, it's rotated, deal with it. Yeah. You should be glad that I'm rotating things for you. You people who use JavaScript versions. I'm not really sure.
Yeah. Why would you do that for a game?
This actually was such a problem that we didn't allow rotating of any of the sprites. And you can actually see that our memory footprint is a little bit larger because of that. So if you're the guy who wrote Texture Packer and you're watching this, or if anybody watching this knows the guy who wrote Texture Packer, tell them that things are not working correctly. Feel free to contact me if it's my misunderstanding.
That's a copy.
But presumably you could.
Yeah.
You could export as XML and then just munge it back into JSON?
So
that way you get the right information?
Presumably we could just, parse it into XML and then munge it into JSON and things would be kind of sort of good.
Yeah.
And I suppose you could. I don't think you would I wouldn't personally want to work with XML, but that's just me. But you certainly could, I think.
Well, for the accuracy.
Yeah.
Yeah, so this is my philosophy and has been as a game developer for a number of years. It's just data.
Yeah.
And anyone who is willing to go fight on a hill to have data in one format or another deserves to stay on that hill. Right? It's just data. It's binary information at the end of the day. Who cares what format it is? The format that you should care about is the one that's easiest to use for your artists and your designers, and then the fastest to load into memory for your end users. So XML, whatever you want to do, you have to be very pragmatic about this stuff instead of dogmatic. The more dogmatic you are, the less useful you are to a team. And that's my dogmatic viewpoint.
Okay, so the next question is, in Unit 4A, Quiz 2 of the Atlas unit, why do you define the variable half in the _drawSprite internal function? Couldn't you just pass the sprite properties directly into the drawImage call? And I was looking through this. I actually didn't remember the half object there. And as far as I can tell, Colt, please correct me if I'm wrong, but I think it was just a bit of code cruft where we were moving stuff around and changing the code base for the client-side version, since it's not quite the same as the overarching game that also has server-side components, and we just didn't remove that.
Okay. Cool. So another question from Dave in Grovedale. Can I still participate in the contest if I'm not an artist and my monsters closely resemble green squares? No. No, just kidding. This would be my first attempt at building a game, and I have a lot to learn in the next months. Graphics may not be my focus. So a couple of suggestions. obviously you can participate. There's a question later about possibly some free artwork sites that we've been looking into.
And there are a lot of good ones.
The other thing is, as Dan pointed out, is team up with some other people. Maybe get a crack team with programmer, artist, biz dev.
Yeah, you got to have a biz dev person. Someone's got to yell at everyone.
So definitely.
I also want to point this out too, is that a good game doesn't always need great graphics. Everyone stop what you're doing right now, and open up your laptop or your Nexus 7 or your Android phone, because that's all that exists, and Google for, quote, the hardest game in the world.
Oh, are you talking about Dwarf Fortress?
This is a very simplistic, artistic-wise JavaScript game that will put your blood pressure through the roof.
Yeah.
It's just squares. It's like squares and lines and checkerboards, but it is enthralling in how deep you get into this game and how angry and how emotional it touches you. Like, for a week and a half, I was just angry at every human being I met while I was playing this game. So great games don't need great graphics. It just really, really helps.
Yeah.
Good point.
Okay.
If the game is running only on the client side and we don't have a server side, how do we prevent cheating with HTML5 and JavaScript? For example, tower defense or bubble shooter games. Do we have to think about that in the contest?
So no, you don't have to think about that in the contest. We're not covering server side stuff or preventing cheating or anything like that. But the other question is, do you really need to worry about that for what kinds of cheating do you really need to worry about for your specific game? And we actually touch on this a bit in the input unit, I think. Correct me if I'm wrong. About ensuring a fair level of gameplay.
Yeah, that's actually something we cover, as Sean said. For example, if you're using a mouse versus a keyboard, right? You would have additional angles that you could shoot at. So we covered that, and that's actually covered in detail in the code as well, like how to solve that problem. What is not solved is sort of the whole server side in this course, and like we said, we are already sort of thinking about a second course that would do the server side, the matchmaking, the
verification and
game logic on the server. So I don't think you have to worry about that specifically for the contest as well. Right. And just to take a step back here, for those of you that may have just tuned in and this is the first time, we are running in parallel with this course a contest. So more information about that is on the Udacity site. So you can go to the Udacity course. There's a
link to the wiki up on the top right, and just go to the wiki. Yeah. It'll have a link to it. So
it'll have all that information in there.
Yep.
So, okay. How do you have a HTML5 game? How do you give an HTML5 game a preloader like most Flash games have? So
do you want a preloader?
Well,
is another question.
Right, that's a good question. But there's a bunch of things you can do with progress bars and things that you can track while you're loading. For example, XML HTTP request level 2, as you're pulling down things, there's actually in XHR level 2, there's new progress events. You can actually check on the exact progress and then display that in an HTML progress element. There's now a new element for that. So those are some simple things you could be doing. There's actually, so Colt, maybe you want to speak a little bit about the instant play and techniques that people have used to sort of delay getting some of the things from the server and get something up and running as soon as possible?
So I'm going to caveat this with the fact that we have a whole unit later on in the course that talks about asset loading. And most importantly, we cover this from the concept that you should be building some sort of asset preloader or asset loader in general, and then part of the quizzes there is actually kind of building up this phased preloader concept. And we actually talk about how Grits is put together, where there's actually multiple phases of loading inside of Grits. Like the initial HTML is loaded, and then when you click Quick Game, effectively what happens is after you've connected to the server, you get all of your JavaScript. Then as soon as your JavaScript is done, then we actually go parse that JavaScript and then kick off a secondary call for any additional assets that JavaScript has done. So you kind of get like these multiple fork and join situations of asset loading where we kind of come back and forth. So I'm going to caveat all of this that I'm about to say with the fact of stay tuned, there's good information to come. Now to get on with my babbling. So instant on gaming is probably one of the most important things about web development that game developers do wrong. So if you look at any of the statistics out there today, you can find information that says 60% of your users will leave your website if they don't see pixels on the screen in the first 3 seconds, right? So if you look at especially on mobile, right? If you grab one of these devices and all of a sudden you're working on basically a ham radio network, right? And actually downloading 25 gigs of image data because your website's waiting for it, you realize that you're creating a crummy user experience. So because of this, you really need to adopt the concept of instant on gaming. If you actually check out my blog at mainroach.blogspot.com, in my video section, I have a full video that talks about this and about instant on gaming, what game developers can learn from the web and vice versa, where it comes down to get something on the screen as fast as possible, right? Load the first 3 megs or whatever you can get there in 3 seconds. And then entertain the user. Put an elephant in a tutu, have them pop balloons, or solve a puzzle or something like that, right? And while they're sitting there with this mental exercise, be downloading the rest of the data behind them. And then with modern HTML5, you've got local storage, IndexedDB, file system operations. You can actually cache this stuff to disk, and this is where JavaScript and the HTML5 platform actually starts feeling like a native environment, right? You can actually download data, cache it to disk, fetch it from disk later if you need to, and this is sort of the crux of how game developers have been doing this for years. I'll give you a little preview of this. Back when the Nintendo 64, we were still a cartridge-based system. One of the benefits of cartridge-based systems is basically the latency for loading assets into memory was 0, right? You didn't really have to wait for a level to load. It was just all in memory as it was, right? And you saw when the Nintendo 64 came out, you also saw the Dreamcast come out, as well as the PlayStation 1. Now, the Dreamcast and PlayStation 1 were actually optical disk drives, which had a much slower seek and read time than standard ROMs of the day. And because of this was actually the birth of the loading bar, right? Sitting at this horrible image that's like loading, 5%, 10%. And people like, I just want to play Tekken. Oh my God, what is going on here? Right? Like enough time to get up and go get a beer and come back and realize that you already lost your match. It was definitely the birth of an era, and I think that programmers still don't do it well enough. I think modern consoles like the Xbox 360 and the PS3 did a great job of actually requiring certification or to actually get certified to ship a product on the Xbox 360. You had to make sure that there was no point in your game in which the screen was still for 5 seconds. Right? So you couldn't actually just have a loading bar that just said loaded. Like you had to have something animating or something distracting the user, or imagine a cat chasing a laser, right? Like you gotta keep them moving. You gotta keep them thinking about what's going on. And so I think part of loading data and asset loaders all comes down to it's all about the user experience. Load something short, load something quick, entertain the user, and load something big afterwards. And that should be the end of my babbling.
Fantastic. We have a question from the audience.
Yeah. So it's regarding our course. So some of the exercises in Unit 2 still were having dependency on the variable names and like how you place the blocks, how you write the code. So I stumbled upon them a couple of times. Like, is this due to the verification thing, or like?
So the question is, there's still some issues with the grading scripts, basically depending on certain variable names, for instance, and there's not a whole lot much of a way around that, because we need to be able to grab onto something, either a variable or a spy onto that variable or something. And in order to do that, we need to know the variable name. There's not a good way around that. What we can do is put a few more notifications on there saying, "Do not change this." But really, we need to latch onto something, and we know the name of it to do that.
I see.
So.
Okay. So another question was like hosting. With respect to if you remember a web application course, we hosted our like the partial web app and then submitted the link. So we got both like a completed web app as we were progressing, and then the link and when we submitted the link, it used to verify, probably parse the code, or it just sent the request and response and everything. But this seems to be a little bit different from the previous style.
Right.
Here, the JavaScript checker seems to be running, verifying our code. So, is this going to be like this, or like do we have something like the self-hosted version of small portions of the game?
Okay. So the question is from people who have done the web development course, the way things were graded in that course is very much different. Because you were just given a URL, and the site actually sent off a request and did a bunch of site scraping essentially, and made sure things were the way they were, and when you requested certain things, you got certain response codes back, et cetera, et cetera. We're not going to really be doing anything like that, mainly because this is entirely client side. We may very well be doing something like that for the server side course.
Right.
If we do, I want to find a better way to do that, because I was the one who had to write all of that. And manually scraping arbitrary websites is very painful.
So how would you advise us to host the small portions of the game which we are developing? Like, we seem to be writing our code in the block, and then I'm storing my code in the version control system, but that isn't a full product, or it isn't progressing towards the complete game yet. So how do you advise that we build? I saw some of the people in the forums are actually hosting their, like I saw that
Sure.
robot rotator
Yeah.
hosted somewhere.
That's probably the best way, either on
Yeah.
GitHub, on your own site.
Yeah, and then actually hosting it. App Engine is a great way of doing it, since
Right.
we're not doing any of the additional heavy lifting server side wise. So we're basically just, if you host it on App Engine, for instance, you would basically just host the single index HTML file, let's say, and then load everything in from there as necessary.
Okay.
So it can be fairly bare bones right now. So you could probably host it wherever, but App Engine is free.
Okay. Yeah.
Or localhost.
Or localhost. You can always do that. Run your own web server
Right.
off of localhost.
Like if you have a Mac, Python comes with its own web server.
I mean, I think I didn't
Right.
phrase my question properly. It's not about my question about hosting. It's about like the practice of like to incrementally develop our game
Okay.
towards the end.
Okay. So
So-
more about Git and versioning and all that stuff.
Like for example, by unit 2, I must have completed some portion of the game. By unit 3, I must have added more to the portions of the
Okay.
game, and then so in order to take the units in such a way that I build parts of the game towards the end. So,
Okay.
are we doing something like this?
Well, I mean, it's going to look very much like the end result of grids with
Yeah.
the client-side portion of
Yeah.
that. So that's a good thing to sort of keep comparing against.
Okay.
That's the closest thing you're going to get.
Yeah, well, and one thing that I would like to do, I just haven't had time to get around to it yet, is just
Right.
packaging up everything that a certain quiz needs, let's say, into a single zip file, so that you can run localhost wise on your own computer, and just putting that in the instructor notes down at the bottom of the page. I'm planning on doing that. The main problem is just what is the highest priority. So that is, if that would help you, I will definitely try to bump that up.
Yeah, we're very happy to give you all free food, because quite frankly, you're just a bunch of crash test dummies at this point.
Yeah.
We are very, very appreciative and humble at the fact that you are willing to be crash test dummies for all of this. So thank you very much.
Yeah.
With your patience and honesty and bug finding and through
Yeah.
all of this. It really helps us make a better course, a better technology stack, and really it's going to help students for years to come. So thank you for your patience, and enjoy the free food.
Yeah.
But we're so grateful too. How is that possible that we could just be generating gratitude without any negative
Right.
consequence?
It turns out it's not zero sum.
My question is on the topic of like instant on and asset management, sort of, but more on the logic side, like game logic. So, like right now, we're drawing to the canvas every 30th of a second, and that could be anything arbitrary. But we're still like doing everything at once, like at this interval. I just want to, I know we're going to get into this, but just to think about it in advance, do you typically have multiple timers and multiple loops going on? Like one for drawing, one for like logic, one for like parsing, and how do you
Right,
do that? Just
yeah.
generally, just to start thinking about it.
Okay, That's a good question, and that's a good one for Colt, actually. So the question is basically, do you normally have a whole bunch of different timers and different loops essentially going on, and how do you manage that? Like your rendering loop, your game logic loop, et cetera, and are these going at different times? So this was... And
The
you know,
elephant
your,
in the
and
tutu.
your event for the elephant in the tutu.
The elephant is actually, let's address the elephant in the room.
Yes.
First.
In the tutu.
So what you're kind of hinting at here can be a separate Udacity course in and of itself. And I'm not signing up to do that course. I'm just letting you know there's a lot of content there.
I took that as a sign up.
Typically, again, it all comes back to the structure of the language, defining how the programmers can realize their influences over making great content, right? So if you're writing a modern graphics engine and event processing system using C++ for desktop or console, then typically what you're doing is you actually have the concept of a multi-frame, multi-threaded rendering engine, right? So you've actually got one whole thread dedicated to just what we call logic, right? So you're just doing path finding, entity update, collision systems, things along those lines. Then you have a whole separate thread that's just dedicated to rendering, right? So finding what polygons are visible, what data needs to be pushed to the GPU APIs, what textures need to be swapped in and out of the LRU cache, things along those lines. Then you've got a whole separate thread that's a network thread that's just sitting there listening to what's coming off the wire, a separate audio processing thread. You probably got some tax in there from the operating system that's underneath it. There's a lot of things going on. At the core of this simulation is a very simple setup, a very simple architecture that's been around since the late 80s, and it's just the concept of multi-threaded programming or concurrent programming. This is in languages that allow proper concurrent programming and actually allow you a memory model to use and abuse concurrent programming. JavaScript is not one of those languages. So JavaScript is single-threaded. It's what we call single-threaded, right? So you basically get a request from request animation frames, and you've got 16 milliseconds to do all of your compute, update, translation data, physics, culling, boundary collection, and then rendering. And that's done in 16 frames a second, right? Now, when you start translating over to other languages, you can actually get to multi-threaded rendering, and that's a bigger thing. If anyone in the room is interested more about multi-threaded programming, there's the only book that I tell people to get. It's called The Art of Multiprocessor Programming. It is the only book you need. Start there. It uses Java as its examples, but you can't find a better piece of tome to really break the ice and teach you how to program multi-threaded environments better. The takeaway for JavaScript though is that typically you've got one request animation frame callback, and you do everything there, and then you get your events that come in from either WebSockets or your input handlers, and you kind of handle that. You kind of just cache those and then handle the results of those inside of your RAF callback a little bit later. And there's lots of nuances of why you don't want to do it inside of your input callbacks, and we talk about that inside the input unit as well. I wouldn't suggest multiple timers. That actually is just going to screw up your frame processing time a lot more. Really what you should be doing is if you need something to tick at different intervals, I would highly suggest just kind of getting a date.time.now, and then just sort of figuring out how long it's been since your last update. And once you've reached a threshold, then do the processing. Adding more timers is not going to help you be mentally cognizant of the flow of execution, which is critical for game development. And it's also going to make it a lot harder to port your concepts to other platforms or other languages if you're going to go that route in the future.
Thanks.
Okay, great. So we're out of time. Let me just
Get him off the
so
screen.
a couple of final things. So one of the questions we mentioned we were going to get to is the free resources for games.
Mm-hmm.
There's a freesound.org.
Freesound.org.
Did you find any other?
Freegameart.org, I believe, is another one that's specifically images, especially sprites, that you can go to. That has a whole bunch of free sprites and free resources in that regard. There's also a bunch of 3D stuff if you eventually want to go that route. There's a lot of good stuff that I've found linked from, for example, the Unity 3D answers community, where they have just lists of free resources for textures and things for 3D, free sounds. Not so much in the way of sprites, though, because Unity is about 3D.
So if you find
games.
any, if you're working on it, definitely add them to the wiki, and maybe this is where your tool can come in handy, Tony. All right, so we will continue to go through these questions
And the previous ones as well.
and
tried to
add
get
answers
everything.
in line. So we will not just leave it here, but we're out of time with the live stream. So I want to thank everyone here in the room for coming to the event. The next event will be exactly 1 week from now, or actually a week minus 1 hour. Starts same time.
And we're in the same room
Same
now.
room. So everything will be pretty familiar. And we'll be in this room on all of those Mondays after that. So we'll have 6 more sessions. So thanks, Colt, for dialing in and through the Hangout. Thanks a lot. And appreciate you all for coming.
Thank you guys.
Thanks.
Yeah. Okay.
All right. And we'll hang around a little bit more for
We're here. Yep.
There's probably still some food left.